For lesson 2.8, proportions and indirect measurement. So the first thing we have is a vocab term, similar figures. They have the same shape, but not always the same size. So turn to your vocab section, get that down. And a couple of examples of similar figures would be if you had a right triangle. So one is tall and skinny. The other one's shorter, but just as skinny in proportion. A couple of examples that would not be similar figures is if you had a tall, skinny triangle, but then a short, wide one. So those do not have the same shape. Turn to your notes, 2.8, proportions and similar figures, get that titled. Our essential question is, why do similar figures allow us to solve for missing information? So the first thing we're going to take a look at is two similar figures. Here, what this says under example 1 is triangle GFH is similar to triangle XYZ. So the first thing that we want to do with this example is identify the corresponding sides and angles. And there's two different ways to do that. One way is to look at the similarity statement, and the other way would be to actually look at the figures. So when we're looking at our similarity statement, or actually let's look at the figures first. So when we look at the figures, we've got side GF corresponds or is in the same place on the different triangle to side XY. When we list sides, so GF, we put a bar above it, and that is corresponding to XY. Looking at the similarity statement, we have the first two letters in the similarity statement for triangle GFH are GF, and the first two letters in the second triangle are XY. So that's a second way to identify the corresponding sides. Again, looking at the triangles, we've got side FH is in the same place as side YZ. So we would say FH corresponds to YZ. And looking at the similarity statements, again, FH and YZ are in the same spot in the different triangles. And finally, we've got the last side, GH, corresponds to XZ. And looking at the similarity statements, we've got GH corresponds to XZ. So those are the corresponding sides. When we take a look at the angles, we've got angle G corresponds to angle X. So those are angle symbols. And then we've got angle F corresponds to angle Y. And finally, we've got angle H corresponds to angle Z. And again, looking at the similarity statements, we've got G and X listed first, so those are corresponding angles. F and Y are listed second, so those are corresponding angles. And H and Z are listed third, so those are corresponding angles. The second piece of information we're looking for is if we know the length of some of the sides, how can we solve for a missing side? Again, this only works with similar figures, so if we weren't told they were similar, we wouldn't be able to set this up. So taking a look, we've got GF, we know is 12, so I'm going to label 12 on that side in my triangle. The corresponding side to GF is XY, and that's the question that we're looking for, so I'm going to call that A. The next piece of information we have is GH, so I'm going to label that side in my triangle as 10. And the corresponding side to GH is XZ, so I'm going to label that side 6. So we're going to set up our ratios. There's a couple of different ways to do this. I'm going to take a look at setting up the corresponding sides as a ratio. So GF, or 12, corresponds to XY, or A. And GH comes from the first triangle, and so did GF. So I started with the first triangle in my first ratio, so I'm going to start with the first triangle in my second ratio, and that corresponds to, in the second triangle, 6. So once we have our proportions set up, we cross multiply. 12 times 6 is 72, equals 10 times A. And we divide both sides by 10 to solve. Now remember, when you divide by a multiple of 10, you just move the decimal place however many zeros you have. So my decimal point is past the 2 to the right side of the 2. I have 1 0, so move the decimal place 1 point to the left, and my answer is 7 2/10. All right, my next example is looking at scales. There are a lot of people that use scales. When you have a map, you'll have a scale. When you're building a scale or a model airplane, you'll use a scale. Architects use scales when they're creating their blueprints. So the first thing that I notice here is that my scale is 1 inch to 25 miles. So I'm going to set that up as my first ratio. The next thing I notice is the distance between two cities on the map is 3.5 inches. So that 3.5 inches is going to go in my numerator because inches went in the numerator in the first ratio. And the question is how many miles? So that's my variable. Miles goes in my denominator. So I'm going to cross multiply to solve. I'm going to drop my units when I cross multiply. So I've got 1 times m equals 25 times 3.5. So when I multiply 25 times 3.5, I'm going to use the distributive property. So I'm going to split 3.5 up as 3 plus half, or 3 plus 5 tenths. When I distribute my 25, 25 times 3 is 75, and 25 times half is 12.5. So when I add those together, I get 87.5 miles. So that's the distance that the cities are between each other in real life. Okay, so this application has to do with the height of a woman and her shadow versus the height of a building and its shadow. These will create similar figures when you think about the fact that you've got the woman casting her shadow, and if you think about the angle of the sun is what creates that triangle versus the height of the building and its shadow, and again that angle of the sun will be the same on both. And they both create a right angle with the ground. So if you have two congruent angles in the triangles, they create similar figures. The next thing I notice in this question is that it's asking us to find the height of the building to the nearest inch. So what I will do is convert the 5 feet 8 inches entirely to inches, as well as her shadow and the shadow of the building. So to do that, remember there are 12 inches in 1 foot. So 5 times 12 plus that additional 8 inches for the height of the woman, so I'll label that work. 5 times 12 gives us 60, plus 8 gives us 68. So the woman is 68 inches tall. So I'll label that in my picture. The woman's shadow is 3 feet, so to convert that to inches, I'll multiply by 12, plus that extra 2 inches. 3 times 12 is 36. Plus the extra 2 inches gives me a 38-inch shadow. So I'll label her shadow. Next, we know the length of the building's shadow. So we've got 80 times 12, because the building's shadow is 80 feet long. I'm going to switch to blue now, plus that additional 5 inches. 80 times 12 gives us 960 inches for a total length of the shadow 965. And the question is, how tall is the building? So that's our variable. So when we look at these two figures, we've got the height of the woman corresponds to the height of the building. So I'm going to set 68 over B, the height of the building, and the woman's shadow corresponds to the building's shadow. So because I started with the height of the woman in the numerator, I will start with the shadow, the length of the woman's shadow in the numerator, and then the building's shadow, 965, will be in the denominator. So when I solve this to cross multiply, I get 68 times 965, which gives me 65,620. And yes, you can use a calculator on that. And then 38 times b. So to solve for b, we'll divide both sides by 38. And we get an approximate height for the building of 1,727 inches. So when I divide it, I got 1,726.84, etc. So I just rounded to the nearest inch, and we'll label our answer with inches. So just as a reminder, and sorry, I should have done this first, this unit right here, the 5 with 1 slash is for feet, and the 2 slashes mean inches. All right, our last example. We have people standing along a river trying to figure out how wide it is. So the red person and the green person are 25 feet apart. The green person and the purple person are 12 feet apart. And then the purple person and the pink person are 10 feet apart. So to find the width of the river, what we need to do is figure out what sides correspond to what in each of these triangles. So we've got right angles here formed with the red person and the width of the river, and a right angle here between 12 and 10 feet. And then at the green person, these are what are called vertical angles. And in geometry, which you'll learn next year, is that vertical angles are congruent. Again, as soon as you have two angles in a triangle that are congruent, then the figures are similar. So we have to take a look at the fact that the 25 feet is between the right angle and the vertical angle. So when I set up my proportion, that will correspond to the 12 feet because it is between the right angle and the vertical angle. And then I'm looking for the width of the river. So that will go in the numerator because that is in the first triangle. And that corresponds to the distance between the purple and the pink person, which is 10 feet. That will go in the denominator. So when I solve this, cross multiply, 25 times 10 equals 12 times w. Divide both sides by 12. 12 goes into 25 if we set up our long division. 12 goes into 25 twice. 2 times 12 is 24. And 12 doesn't go into 10, so that's 0. So we bring down another 0. 12 goes into 100 approximately 9 times. So when I round this, I will get W is about 21 feet. And I'm going to go ahead and make those wavy equal signs to show that I rounded. So that's lesson 2.8. Again, you'll get the assignment in class to work on tomorrow. And the first thing I'll do is ask what questions you had over the lesson.